Welcome to the session on conditional probability, tree diagrams. The objectives for this session are to solve conditional probabilities using tree diagrams. Conditional probabilities can be represented using a tree diagram. Let's build up a tree diagram to help us create some formulae. Suppose we have two events, A and not A. Here's our probability of A, and here's our probability of not A. Following the first stage, we're going to have another stage, either B or not B. So here's one branch coming off the A branch, and here's the probability of B given that A has taken place, and the probability of not B given that A has taken place. And similarly, the branches coming out of the not A part. Here we have probability of B given not A, and here we have the probability of not B given not A. So here we represent the conditional probabilities of B given that A has or has not happened. And so we have probability of B intersect A equals probability A times probability of B given A. And similarly for the probability of not B intersect A, and the probability of B intersect not A, and finally the probability of not B intersect not A. A tree diagram is used to show the outcomes of two or more than two events happening in succession. Let's take a look at an example. Suppose a bag contains 4 red marbles and 3 blue marbles. A marble is taken from the bag at random and not replaced. A second marble is taken from the bag. Here are some questions related to this example. Pause the video and have a go. Press play when you're ready to view the solutions. Let's construct the tree diagram related to this question first. So on the first rule, we can either draw a red or a blue. And similarly on the second rule. The probability of drawing a red on the first go is 4 out of 7. Once we've drawn a red, we don't replace it, and so the probabilities on the second draw now change. And so the probability of drawing a red on the second draw is 3 out of 6, and similarly the probability of drawing a blue is 3 out of 6. The probability of drawing a blue on the first draw is 3 out of 7. And on the second draw, if we've already drawn a blue, then the probability of drawing a red is now 4 out of 6. And the probability of drawing a blue on the second draw is 2 out of 6. So for part A, we're required to find the probability that both marbles are blue. In this case, we go down the blue-blue route, as highlighted here. And so we have 3 out of 7 times 1 out of 3 to give us 1 out of 7. Now for part B, we are required to find the probability that the marbles have the same colour. So this is going to be probability of red-red plus probability of blue-blue, which equals 4 out of 7 times 1 out of 2 for probability of red-red plus 3 out of 7 times 1 out of 3 for probability of blue-blue. Giving us 2 out of 7 plus 1 out of 7, which equals 3 out of 7. And this is the probability that the marbles have the same colour. Now for part C. Given that both marbles are the same colour, find the probability that they are both blue. So what's the probability of blue-blue given that the marbles are the same colour? So we're going to use the conditional probability formula as highlighted here. Probability of C given D equals probability of C intersect D divided by probability of D. And this is equal to 1 over 7 divided by 3 over 7. So 1 over 7 comes from part A and 3 over 7 comes from part B. And this is equal to 1 out of 3. This brings us to the end of this session. If you have understood its contents, you should be able to solve conditional probabilities using tree diagrams. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.